Okay, today we're going to talk about indicators. And an indicator is usually a weak acid that has a different color in an acid in a base environment. So a weak acid would be like a big chain of hydrocarbons, like an organic molecule. If it has an H, if it loses that H, it becomes its conjugate base. That's why I said weak acid with its conjugate base. Right up here, it almost is like a buffer system. So what happens if I add OH minus to this? Okay, it eats up the H plus, it drives equilibrium to the right, it takes this color form right here. If I add H plus to this system, it drives equilibrium this way and it takes this form here. And indicators will have one color in an acid environment, one color in a base environment. And we can see that there's an indicator in this paper here, and I'm spraying ammonia, which is a base on there. So when I spray that OH minus, it drives equilibrium to the right, turning it red. And when that evaporates, or I add an acid, or the base goes away, it's going to shift the equilibrium and go back to this form right here. So we're going to look at a couple of indicators right here, and I think we have some bromethymol blue right here, and some phenolphthalein, and some bromocressyl green, and some methyl orange, and we're going to breathe into them because we're breathing carbon dioxide, which is slightly acidic. We have some indicators with a little bit of base added to them to give them their characteristic colors. Okay, so we're going to blow some bubbles. Are you ready to go, Isaac? Mm-hmm. Okay, and maybe I'll get down here. You can grab your cup right there, and 3, 2, 1, we can start blowing bubbles. I'm going to need my safety glasses. Okay. Okay, we'll stop. All right, let's see what we got. All right, now this one is bromethymol blue, and that went from blue to, what does that look like?
Yellow.
Yellow, little tint of green. And the phenolphthalein went from pink to?
Like clear water.
Yeah, like clear water. And the bromethymol blue went from blue to pretty much stayed the same. And the methyl orange pretty much stayed the same. Looks like you're a better bubble blower than I am. Let's take a look at a couple of these indicators and see where they're supposed to change right here. So we're looking at this chart here, and I see phenolphthalein. Now we breathe carbon dioxide out. That has a pH about 5 to 6. So phenolphthalein actually changes pH. I'm going to grab this marker here. Sorry. And phenolphthalein changes about pH of 9. With a tail, it'll be clear at 8, it'll be pink at 10, and kind of that transition point is 9. We started adding base to it, which made it basic, and the carbon dioxide ultimately turned to clear. We have bromethymol blue, and that one right here changes about pH of 7. Notice it started blue and it went to kind of this greenish yellow at a pH 5 to 6. It even gets more yellow if you can get more acid in there, but breathing won't give you that. Bromocressyl green really changes between about a little under 5, so it's probably a good thing when I'm breathing out that did not change colors. And let's see, the methyl orange changes about a pH of 4. Again, that would turn more red if I add an acid. We'll just show you that by adding an acid to those things. But let's see. We'll grab some HCl, throw it in here, and this will go from orange to, from yellow to I'm sorry, from orange to red. Orange to red, sorry. And this one is the Brome Crescel Green. If I add more stuff, we get lower down here so you can see it. And that will go to a really dark yellow right there. If we don't like that, we can add some base and we can switch it. Maybe add a little bit more base. Gotta drop the base a little lower and we can get that right there. Just like we could add more base and turn these back here. They're all reversible systems that we have. So again, an indicator is an acid, weak acid, conjugate base system, one color in the presence of a base, one color in the presence of an acid, and you can switch back and forth. If you are doing a titration lab, what you would want to do, and you are choosing an indicator, you're going to choose an indicator with a pKa near the pH of the endpoint at the endpoint or the equivalence point. So phenolphthalein has a pH around 9 with a weak acid and a strong base. That would be a good indicator. If you do a strong acid, strong base, it's a pretty good indicator because a pH change around 9 will still work out very well with that because there's a huge range where it changes colors. Okay, that's it. I messed